Alright, I want to go over some of the problems from page 21. The first one I'm going to look at is number 16, and it's asking you to complete this chart and then sketch a graph that goes through the points that you're able to come up with. So the first thing I'm going to do is substitute negative 2 in for x, and I get y is equal to 3/4 times negative 2 minus 1. Remember our order of operations here, so we end up with negative 6/4 minus 1. Negative 6/4 is the same thing as negative 3/2. And if you make 1 a fraction, you're going to end up with 2/2. So negative 3 minus 2 is negative 5. And so I get negative 5/2 as my result here. Negative 5/2. Now, the other one is 0. When I put 0 in, I end up with y equals negative 1. So negative 1 goes in. When x is 0, y is negative 1. And when it's 1, you end up with 3/4 times 1, which is just 3/4, and then you subtract 1 from it. That equals your y value. So 3/4 minus a whole is just going to give me 1/4, or negative 1/4 that is, equals y. So negative 1/4 equals y, and then my last one here, sorry, not the last one, the next one is going to be 3/4 times 4/3. Let's put that one in here, negative 1/4. 3/4 times 4/3, and then minus 1. Well, 3 times 4 is 12, 4 times 3 is 12, so you end up with 1 minus 1, which equals 0. So 0 goes in right here. And then lastly, we're going to put in a positive 2. So when we put in a positive 2, it's like putting in a negative 2 earlier, except for we end up with positive 6/4 instead of a negative 6/4 minus 1. So 6/4 minus 1 gives us, let's see, make that 4/4. I guess we could have made it 3/2 again like we did last time, but we end up with 2/4, which equals 1/2, positive 1/2. So that leaves us with the rest of this chart filling out, just putting these as ordered pairs. So we end up with negative 2, comma, negative 5/2, 0, comma, negative 1, 1, comma, negative 1/4, 4/3, comma, 0, and 2, comma, 1/2. Over here. And so all of those go into their spots. Like this. Oh, not going to be able to do it there because it grouped it all together. But you get the idea. So now we need to plot these points and sketch the curve. So I'm going to erase all the work here because I want to make this graph a little bit larger. Just save your points. So plotting our points, we have negative 2, negative 5/2, 1, 2, and then down 1, 2, or we're going 5/2. Think about what 5/2 is. 5/2 is the same thing as 2.5. So if it's negative, it's going to be like negative 2.5. So we're going over 2 and then down 2.5. And then we have 0, negative 1. 1, negative 1/4. So we're just going down just a fourth. 4/3, 0. So 4/3 is the same thing as 1 1/3, and we're staying at 0. And then we're going to go to 2 and then up a half. So it looks like we could be graphing a line here, is what it appears to be. We were to sketch that. Next, I'm going to look at number 26. So number 26 wants you to find the x and the y intercepts. So we have y equals the square root of 2x minus 1. And remember, when we're talking about an x and y axis, or the intercepts, It's where it crosses those axes. So if I've got a point right here crossing that y-axis, the x value equals 0. So when x is 0, we have our y-intercept. So if I want to know the y-intercept here, just make x value 0 and solve for y. So I get 2 times 0 minus 1 square rooted equals your y-intercept. 2 times 0 is 0, and then that gives me the square root of a negative 1. Well, you can't take the square root of negative 1 and get a real solution, so the answer here is no solutions, or no real solutions. So we don't have a y-intercept. So probably, if you're graphing this thing, it's not going to cross the y-axis. The next one is the x-intercept. So to find the x-intercept, once again, if you have where it crosses the x-axis, you're going to have a y value of 0, and then your x-intercept is going to be right there. So let y equal 0, and then solve for x. Square both sides, you get 0 equals 2x minus 1. Add 1 to both sides, and then dividing by 2, you get your x-intercept to be positive 1/2. You could, and then of course you could, to write this out, you could say that it's 1/2 comma 0. That's the location of your x-intercept. The next one I want to look at is going to be number 30. I want you to pause the video. Give number 30 a try on your own. It says y is equal to x to the 4th minus 25. They want to know what are the x and the y-intercepts of this equation. So the first thing we're going to look at is let x be 0 and see what you get for your y-intercept. Well, if x is 0, you get y equals 0 to the 4th minus 25. 0 to the 4th is just 0. Minus 25 just gives you minus 25. So when x is equal to 0, y is equal to negative 25. That was fairly simple. The other one's not so obvious for if you haven't done these in a while. And so if you let 0 equal y, you get your x-intercept. So you end up with x to the 4th minus 25. Add 25 to both sides. And then take the 4th root from each side. So you end up with the 4th root of 25 is equal to x. Well, let's try to narrow this down a little bit more. What is the 4th root of 25 equal to? Well, we know that 25 breaks down into 5 times 5, because the square root of 25 is 5. But 5 doesn't break down any further unless you look at this as being broken down into the square root of 5 times the square root of 5. And this is the square root of 5 times the square root of 5. That's one way you can look at it. So the 4th root of 25 is the square root of 5. And don't forget, you can have you can have a positive or a negative value here for that. So you could say that the x value, let's see, you can say that the x value is equal to a negative square root of 5, or x is equal to a positive square root of 5. Or if we're writing these out as intercepts, you can say it as negative square root of 5 comma 0, square root of 5 comma 0. So these are your x and your y-intercepts here. Now, this might be kind of confusing for some students, so let's look at just one more way that you could do this problem, or get the 4th root of 25. Clear up some space here. You can look at this as an exponent. So remember, if we take like 25, the square root of 25, that's the same thing as 25 to the 1/2. Well, if we want to do the 4th root of something, say the 4th root of 25, we can rewrite this as 25 to the 1/4, like that. And then we know that 25 is the same thing as 5 squared. So we could say that this is equal to 5 squared, that's 25, raised to the power of 1/4. And remember when we had this back in algebra, if we had something like x to the third, the whole thing squared, that's the same thing as x to the sixth. You multiply these two. So if I multiply these two, I get 5 to the 2/4, which equals 5 to the 1/2. And I know 5 to the 1/2 is the same thing as the square root of 5. But you have a positive square root of 5, and you also have a negative square root of 5. So therefore we end up with these two values again. Okay? I know that one is a little bit more challenging because you haven't seen many things raised to the power of 4 that you're solving for, and that's why I chose to use that as an example.